Hi guys, and welcome to lecture 3 for chapter 15. Before we talked about some of the different sources of energy and some of the different energy terms, in the second lecture we also did a deep dive into what fossil fuels were, some of the benefits associated with fossil fuels, and then some of the drawbacks. Now today we're going to be talking about reaching for fossil fuels, specifically developing new technologies and extraction methods to deal with the dwindling resources associated with fossil fuels, and talk about different ways that we've kind of extended our reach for fossil fuels with new and developing technologies. So it should be noted that one of the reasons we're beginning to reach for other methods of extraction for fossil fuels is that we are simply running out of conventional fossil fuels. Remember that fossil fuels are inherently non-renewable. Eventually we will run out. And in order to estimate how long it will take to run out of a given fossil fuel resource, we calculate this using the reserves to production ratio. Basically, the reserves to production ratio is the estimated amount of remaining reserves that we have for a given fossil fuel divided by the current annual rate of production. Basically, this is how much is left divided by how much we are how fast we are currently using it up. For coal, the estimated reserves to production ratio leads us to calculate that we have about 153 years left of coal. For oil, we have about 51 years, and for natural gas, we have about 53 years. And in addition, something that we should note is something called peak oil. Eventually, the extraction of any non-renewable resource will peak and then gradually decline. If demand holds steady or rises after that peak, a shortage will result. Basically, peak oil refers to the point at which production of oil, one of the main conventional fossil fuel reserves, reaches its highest point, and then production begins to decline. For the United States, peak oil was in the 1970s. Worldwide, peak oil was around 2005. It's very difficult to model because of innovations in extraction technology. Basically, we are getting better and better at extracting oil, but the fact remains that we've already had our peak in peak oil, and we are beginning to run out. So this is one of the reasons we are beginning to reach for fossil fuels in different and novel ways. Now, the first way that we are extending our reach for fossil fuels, particularly for coal, is mountaintop removal. Mountaintop removal should be very familiar to you guys. We all went over this in Chapter 11's different mining methods because this is a primary way to mine for coal. Basically, as a reminder, mountaintop removal mining basically involves blasting several hundred feet of a mountain completely away and exposing a given resource that we want to extract. Normally for fossil fuels, the given resource is going to be coal. However, there are severe impacts. Again, we went over this in Chapter 11, but with mountaintop removal, forests are entirely clear-cut, topsoil is completely removed. Unstable rock as a result of mountaintop removal mining causes landslides and flash floods. It also degrades immense swaths of habitat through acid mine drainage, as rainwater will trickle down through the newly exposed toxic metals, wash them away, and then percolate down below the mountain into the valleys. So these have enormous impacts on the ecosystems around them. When it comes to oil, the best way to extend our reach for oil reserves are going to be through secondary extraction. Recall how in primary extraction we basically drill a hole into the ground, and the pressure of the oil will actually push the oil up into our oil rig on its own. It will it's self-propelling upwards. However, after enough pressure has subsided and the oil is no longer pumping itself up, we can extract additional oil through secondary extraction. Secondary extraction essentially involves us injecting solvents, normally some kind of pressurized water, into the oil reserve and actually pushing the oil up and out in order to pump it up into the rig, or continue to pump it up into the rig. Now, this is normally going to be a lot more expensive than primary extraction because we're actually investing energy to physically pump the oil out of the ground. And so it is only going to be profitable when oil prices are very, very high. Additionally, we can also continue to extend our reach for oil reserves by doing tertiary extraction. In this case, pressurized steam is going to be pushed underground to get the very last bits of oil in an oil reserve. However, this is only going to be profitable when oil prices are extremely high. So normally only primary and secondary extraction are going to be the main methods to extend our reach for oil reserves. An improved version of subsurface mining is going to be something known as directional drilling. Remember that in subsurface mining, we drill down and then out and form these elaborate channels in order to get different pockets of fossil fossil fuels. That is gradually being replaced with something called directional drilling or horizontal drilling. Directional drilling involves drilling techniques that bore into the ground at a near vertical trajectory and then curving out in order to directly access the different pockets of fossil fuels. This enables workers to follow layers of horizontal deposits, and it decreases costs as well as it decreases environmental impacts. It is a much better way to mine for fossil fuels in that it really mitigates the severe environmental impacts associated with subsurface mining, and it is far more cost efficient. Next, we're going to be talking about one of the most controversial methods of extraction for different fossil fuels, and this is going to refer to hydraulic fracking. Basically, one of the problems that engineers were tasked with is that it can be extremely difficult to access oil and natural gas deposits in shale rock or in shale rock that is buried underneath the ground. Now, this is where hydraulic fracking comes in. Hydraulic fracking is essentially a method of extraction where chemically altered water is injected deep into the layers of rock at extremely high pressures in order to break the shale rock apart into pieces. After the shale rock has been broken up, sand, glass, or different pieces or shards of material are shoved up into those cracks to keep them wide open so they don't fuse back together under serious pressure. Once the cracks are held open, oil or natural gas or whatever fossil fuel that we are trying to extract can flow freely and be pumped up into the rig and shipped off to different areas for processing. Now, this is one of the most controversial methods of fossil fuel extraction, particularly because of some of the pros and cons associated with it. On the pro side, this has led to a boom in fossil fuel extraction in the United States. It has dramatically reduced our dependence on foreign oil and other fossil fuel sources, and most of the fuel that results from hydraulic fracking is natural gas, which is one of the cleaner burning fossil fuels that emits far less carbon dioxide or other secondary pollutants. However, on the con side, there are some serious impacts associated with hydraulic fracking. So one of the most substantial impacts associated with hydraulic fracking happens to be with drinking water. In many cases, all of this shale gas is going to be beneath aquifers that different residences, cities, towns, etc. rely on for drinking water. So whenever we are breaking apart that shale oil, basically some of that chemically treated water or some of those fossil fuels can leach into the groundwater and essentially contaminate it where people are actually relying on it for drinking water. This can cause some major problems. In addition to that, some of the pollutants associated with hydraulic fracking will also pollute surface water. So not only are we polluting groundwater that people are relying on for drinking, but we're also polluting secondary surface water reserves. So there is literally no water left for these people to drink. Basically, the treated water that is used to push out these fossil fuels from the deep underground and these shale rocks is just kind of returned back into these secondary reservoirs where they can result in major pollution. And in addition to all of this, as if that wasn't enough, there's a lot of toxic gas emissions that are also as a result of shale extraction. A lot of those chemicals used in the chemically treated water can leach out of the water and eventually cause air pollution, as well as some of the methane from the natural gas can float up and cause secondary methane pollution. So there is a lot of pollution associated with hydraulic fracking, but it is a serious pro in terms of reducing our energy dependence and fostering an economic boom within the United States. Now, another method we can use to extend our reach for fossil fuels, particularly fossil fuels such as oil and natural gas, involve offshore drilling. Basically, oil and natural gas are both formed from pelagic processes. Basically, phytoplankton over many, many years die and settle onto the ocean floor, with which they are buried, subjected to heat and pressure over millions of years, and as a result, we get oil. So because oil and natural gas originate from ocean processes, it makes a lot of sense that most oil and natural gas is actually found underneath ocean floors. So in order to get to these oil reserves, we employ something called offshore drilling, where essentially we establish oil rigs way offshore in very deep water. Currently, about 35% of oil and about 10% of natural gas comes from offshore drilling, and offshore drilling has dramatically improved our access to these fossil fuel reserves. However, at great cost. If there's any sort of mechanical failure involved on these rigs, it can result in a major oil spill. Basically, basically the deep water in which these oil rigs are found make it very, very difficult for quick responses once an oil spill has begun. And so typically if an oil spill occurs on deep offshore rigs, it can cause enormous damage. Keep in mind the Deepwater Horizon oil spill back in 2010 that released thousands and thousands of crude oil into the Gulf of Mexico and resulting in enormous pollution to many different marine habitats. So in conclusion, we're reaching for fossil fuels simply because our conventional fossil fuels are running low. Essentially, we have about 150 more years of coal supplies, about 50 years of oil supplies, and maybe 50 years of natural gas supplies, in which case unconventional fossil fuels could extend our reserves for centuries. However, there are some serious downsides. Unconventional fossil fuels aren't really used right now because they're difficult to extract and process, meaning that they have very low net energy and very low ERI. In addition, these unconventional fossil fuels are even more environmentally destructive than conventional fossil fuels. They consume very large volumes of water and natural resources. They're incredibly difficult to transport. Often they are blown up or pipelines leak, and they can continue to contribute to climate change. Just extending our reach for fossil fuels only solves the problem of our energy reserves. It doesn't solve the problem of what we are doing to the climate through CO2 emissions. So there are some inherent benefits to perhaps extending our reach for fossil fuels in the short term, but in the long term, we really need to think of an alternative solution. However, that is everything we have for the Extending Our Reach for Fossil Fuels lecture. I hope you guys enjoyed it, and I'll see you guys again for our solutions for energy conservation and efficiency.